Hi guys, thank you for watching my previous videos. Some of the students they feedback to me, they would like to take a look at myself and they want to know who I am. So this time round I'm going to make a video with my face over here on the right hand corner. So I hope you can see me. Yeah, hello. Yeah. Of course I'm not going to make my face as the main attraction here, because I still want my students to focus on the materials I am going to present rather than my face over here. But yeah, I listen to your feedback. That's why I'm making this video with my face. So yeah, without further ado, today I'm going to talk about the topics on properties of circles. Okay, I'm going to talk about the concepts of properties of circles. So before you can do any question on properties of circles, there are some rules you have to remember or memorize before you can actually do questions on properties of circles. So without further ado, let's take a look at rule number one. So let me state rule number one first. So rule number one is angles in a semicircle. Okay, so this is rule number one. So you can see that I have two semicircles here. So this is semicircle one. Okay, so let me make use of this semicircle one first. Okay, and so if you have a semicircle, and I hope you can identify this is actually the diameter. This is actually the diameter of the semicircle. Okay, so this is the diameter of the semicircle. And if you want to form a triangle, okay, so let's say, okay, let me make this line thicker. Okay, so if you want to form a triangle inside this semicircle, so we get one more line. Okay, so the point here is inside this semicircle, and if you were to form a triangle inside this semicircle, these two lines which you are going to connect them. Okay, which you are going to connect them. Okay, so this line and this line, let me change the color so you can see it better. So let me use a red color here. So you have line one here, and then you have another line here. So these two lines, they should meet at one point on the circumference. Okay, so as you can see here, right, so you have this line one, and then you have this line two, and these two lines must meet at one point on the circumference. So in this case, this is the point on the circumference. Okay, so if these two lines meet at a point on the circumference, and you should get a right angle triangle here. Okay, so you should get a right angle triangle, okay, in this semicircle. Okay, so let me elaborate this rule number one, angle in a semicircle, once again. So I will make use of my semicircle 2 here. So once again, this is your diameter of the semicircle, right? And this is the circumference of the semicircle 2. Okay, so I hope you have no problem. And then right now, if I want to form a triangle inside. Yeah, once again, let me change the thickness of this first. Okay, if I want to form a triangle inside the semicircle. Okay, so if I want to form a triangle inside the semicircle. Okay. Okay, good. So can you see that these two lines? So you have this line 1 and you have this line 2, right? And then they meet at one point on the circumference. So this is the point where they meet at, this is the point where they meet, and this point is on the circumference. So it must be on the circumference. Okay, once again. Okay, it must be on the circumference. Okay, and therefore you should form a right angle triangle. Okay, you should form a right angle triangle. Okay, so that's how this rule can be used. Okay, so this is how this rule can be used. So generally, what do you have? Okay, generally what do you have before you can use this rule number 1 is, so you must see a triangle inside this semicircle. So in this case, let me use a different color. So you have this triangle, right? You have this triangle, right? Inside the semicircle, and these two lines must meet at a point, and this point must be on the circumference. Okay, and if you meet these requirements, and you should be able to get a right angle triangle. Okay, so that means this angle is 90 degrees. Okay, so similarly, so you have a semicircle here, and then you have two lines that meet at a point, and this point is on the circumference, right? This point is on the circumference, and so therefore you should get a right angle triangle inside this semicircle, and therefore this means this angle is actually 90 degrees. Okay, so this is how rule number 1 can be used. Okay, so let me move on to rule number 2. Okay, so for rule number 2, so I have my circle 1 here, but before I go on to draw on the circles, let me list down what is rule number 2. So rule number 2 is angle at center is equal to 2 times the angle at the circumference. Okay, I'm sorry. Let me clear my throat first. Okay, yeah, I'm done. So yeah, let me try to explain to you what this rule is all about. Okay, so first thing first, let me use this circle 1 to illustrate the point. So first thing first. Okay, so looks like I have to make it thicker. Yeah, good. So everything here, I need to make it thicker first. Okay, good. So first you should have this. Okay, and then here to here. Okay, so to make life easy, let me just denote this is the origin. This is the origin. So this is the origin of the circle, and it's denoted by my letter O here. Okay, so if you have the origin here, and then if this is the origin, so which is the angle at the center? So clearly this is the angle at center, right? Okay, before I do it, let me move my letter O to here. Okay, so this is the origin of the circle, and the angle at center is, it can be this, okay, or it can be this. Okay, so which one you should choose? Okay, so which one you should choose? The important thing is you need to be able to identify the angle at the center. Okay, so I will teach you how to choose. Okay, so let's choose this is the angle at the center first. Okay, let's choose this as the angle at the center first. Okay, because if you choose this as the angle at center, then when you look from this angle at center and you look up, okay, you look up, means you look from the bottom to the top, okay, you look up. So the direction is indicated by my green arrow here, and you will realize you have a angle at the circumference here. Am I right? Am I right? So if you have an angle at the circumference here, then you can actually make use of this rule. Angle at center is 2 times the angle at the circumference. So what's the meaning? So let's say if the angle at center is A, okay, the angle at center is A, so the angle at center, no, the angle at circumference, I'm sorry, so the angle at the circumference is A, so the angle at center is actually 2 times this angle at circumference. So the angle at center is 2 times the angle at the circumference. Okay, so angle at center, which is this one, is actually 2 times the angle at the circumference. So this is your angle. This is your angle at the circumference, right? And then this is the angle at the circumference. Okay, and then what? Then this is your angle at the center. Okay, so yeah, this can be a little bit confusing. That's why I'm going to demonstrate to you with another example, right? So I have another example here, and let me get rid of this cross first. Okay, so first thing first, you have the origin. Okay, you have the origin denoted by O here, and then you should have you should have what? You should have an angle at center, and subsequently you should have what? Angle at the circumference, right? So let me make the lines thicker before we continue. Okay, good. So this is good enough. So once again, so let me make 2 more lines. Okay, great. Okay, so you have the angle at center. So let me connect it. Okay, great. So just move it here. Okay, then move it here. Okay, good. So right here, so once again, so first thing first, we need to identify the angle at the center first. Okay, so this time round, let me choose this as my angle at center. Okay, so if this is the angle at the center, so I should look up from this angle. So that means this is the angle at center. So I should look up. Okay, what you can actually do is you can actually turn the page around. Okay, that's what I always teach my students to do. So what you can actually do is this. Okay, so first thing first, let me group this first. So if you can't see it, so you can actually turn it around, right? So you turn it around, and I mean you can actually turn your page around, okay? And then you start to see if this is the angle at the center, and you try to look up from this, okay? Try to look up from it, and you realize that there is no angle at the circumference if you choose this as the angle at center. There is no angle at the circumference, right? So you don't see any angle at the circumference here, right? So therefore, you shouldn't choose this is your angle at the center. Okay, so you shouldn't choose this as the angle at the center, because there is no angle at the circumference for you to find out what is your angle at the center. Okay, so let me go back. Okay, let's go back to this. Okay, so back to normal. So right now what you can do is, so this cannot be the angle at the center, so I have to choose this as the angle at the center. Okay, so if this is the angle at the center, so I should look up from here, right? Oh yes, so if you choose this as the angle at the center, and you will see that you have an angle at the circumference in this case, right? So given this angle at center, which is 2 times the angle at the circumference, so similarly, if this angle at the circumference is b, so your angle at center should be 2b. Okay, because angle at center is always 2 times the angle at the circumference. Okay, make sense? Okay, so yeah, so this is the way to identify the angle at center, and then later on, and you can get to identify the angle at the circumference, and therefore you can make use of this rule number 2, which is angle at center is actually 2 times the angle at the circumference. Okay, so let me move on. Okay, so let me move on to rule number 3. Okay, rule number 3 is angles in opposite segment. Okay, angle in opposite segment. Okay, and let me illustrate with this circle here. So let me make the lines thicker. Yeah. So for this rule number 3, you have to form a quadrilateral inside this circle. Okay, you have to form a quadrilateral inside this circle. So copy, paste. Okay, good. So I have already formed a quadrilateral inside this. Okay, so the point to note is, this is your point 1, this is your point 2, and therefore this is your point 3, and then therefore this is your point 4. So all these point 1, 2, 3, 4, they must be, okay, they must be on the perimeter of the circle. Okay, this is the key. Okay, all these points must be on the circumference or perimeter of the circle. So if you meet this requirement, then you can actually make use of this angle in opposite segment. Okay, angles in opposite segment. So which means if this is your angle 1 and this is your angle 3, and then your angle 1 plus angle 3 is actually equals to 180 degree. Okay, so similarly, if you have this is your angle 4 and then this is your angle 2, so your angle 2 plus angle 4 is actually equals to 180, and you make use of the angles in opposite segment rule. Okay, so it's very simple. So if you have 4 points, and they are on the perimeter of the circle, and these 4 points form a quadrilaterals. Okay, these 4 points form a quadrilateral. So quadrilateral. So some of the students, so for the benefits of some of the students, quadrilateral. So what's the meaning of quadrilateral? It means it's a 4-sided polygon or figure. Okay, so if you have 4 points on the circumference, you can see right over here, they are all on the circumference. Okay, they must be on the circumference. If they are not on the circumference, you can't use this rule. Okay, remember that. So you have all these points on the circumference. Okay, and if they form a quadrilateral inside this circle, then you can make use of this rule number 3, angles in opposite segment. Okay, and angle 1 plus angle 3 is equal to 180 in this case, and then angle 2 plus angle 4 is equal to 180 in this case. Can you see that this angle 1 and 3, okay, they are opposite to each other? And can you see that this angle 2 and 4, they are also opposite to each other? Okay, so yeah, that is rule number 3. Okay, and actually I would like to do what? I would like to do rule number 4 on this same page. Okay, I would like to do rule number 4 on this page as well. Okay, so rule number 4 is angles in the same segment. Okay, so angles in the same segment. Okay, what do I mean by that? Okay, so once again, let me give myself some straight lines. Okay, good. So let me make use of this circle. Okay, I need two more lines. Okay, great. Okay, good. So let me link it up. Okay, so with this, so over here, so this point touches the circumference, point 1, and this point 2, it touches the circumference as well, and you have your point 3, and then you have your point 4 here. Okay, so these 4 points must touch the circumference as well. Okay, and if these 4 points, they touch the circumference, therefore this angle A, let me use angle A in this case, and this angle B in this case, so your angle A is actually equals to your angle B. Okay, so this is the rule number 4, angles in the same segment. Okay, so similarly, if this is your angle C and then this is your angle, so if this is your angle C and this is your angle D, so your angle C is actually equal to your angle D as well. And the rule number 4, and the rule here is angles in the same segment. Okay, so nothing very special here. So I have already taught you guys how to actually make use of 4 rules for the concepts of properties of circle. So I can actually do a recap. So that you can have a better understanding. Okay, so the summary here is I will actually divide these 4 rules into 2 categories. Okay, into 2 categories. So this is cat 1 and then this is cat 3. Cat 2. Yeah. So for cat 1, right? For cat 1, what you can actually see is you have rule number 1 and then you have the rule number 2. Okay, for rule number 1 is you have a circle. Okay, let me just draw 2 circles out. So for rule number 1 is angles in a semicircle. Okay, and then for rule number 2 is angles what? Let me refer to it. So this is rule number 2, and angle at center is 2 times angle at circumference. Very good. Okay, so rule number 2 is angle at center is 2 times angle at the circumference. Okay, so for rule 1 and rule 2, okay, so they have similar features. Okay, let me draw it out. In fact, they both, so this is the origin, and then this is also the origin of the circle. Okay, so if you have you have this diameter, and if you are to form a triangle inside this, okay, inside this semicircle, and you should be getting a right angle triangle. Okay, that's rule number 1. And then for rule number 2, okay, for rule number 2 is this. Okay, you must be able to identify the angle at center first. So this is clearly the angle at center, right? So this is the angle at center. And then if you have the angle at center, and then what you do is you look up from this angle at center and see if you have an angle at the circumference. So in this case, you have 1 angle at the circumference here. So if this is your A, so therefore your angle at center should be 2 times A, right? Okay, so if you observe these 2 rules, carefully, okay, if you observe these 2 rules carefully, you should be able to identify they have similar features. Okay, so first thing first, they have for these 2 rules, they both have 3 points on the circumference. Okay, they both have 3 points on the circumference. So I call this point 1, point 2, and then point 3. So similarly, you have point 1, point 2, and point 3, right? So they both have 3 points on the circumference, and they both have something to do with the origin, right? Can you see? They both have something to do with the origin of the circle. Okay, so these are the common features, okay, for the 2 rules. Okay, both have 3 points on the circumference, and they both touches the origin of the circle, or they have something to do with the origin of the circle. Okay, that's why I put it under category 1. Okay, so now let's go ahead and look at cat 2, which is rule number 3 and then rule number 4. So for rule number 3, what do you have? You have angles in opposite segment. Okay, then for rule number 4, you have angles in the same segment. Okay, so for these two, they also share some similar features. So let me point out to you. So for opposite segment, all you need to do is you need to have 4 points on the circumference. Okay, so you have your point 1, then you have point 2, and then you have your point 3, and then you have point 4, right? Okay, and similarly for this angle in the same segment rule, you also have 4 points on the circumference. Okay, so you also have point 1, point 2, point 3, and then point 4. Okay, so they both share a similar feature here, which is 4 points on the circumference. Okay, so if you have 4 points on the circumference, then you should be able to see that if this is your angle 1 and this is your angle 3, so angle 1 and angle 3, they are opposite to each other, so angle 1 plus angle 3 should give you 180 degree. So similarly, if this is your angle 2 and then this is your angle 4, so angle 2 plus angle 4 is equal to 180. And the rule you use is angles in opposite segment. Okay, so for angles in the same segment, okay, they have 4 points on the circumference of the circle, and if this is your angle 1 and then this is your angle 2, so using angles in the same segment, you should get angle 1 equals to angle 2. So similarly, you have your angle 4 here, you have your angle 3 here, so your angle 3 is equal to your angle 4, and the rule you use is angles in the same segment. Okay, so if you have 4 points, you have 4 points on the circumference. Okay, so you can actually make use of rule number 3 or rule number 4. So that is why I categorize these 4 rules into category 1, 3 points on the circumference. Okay, cat 1 is 3 points on the circumference. And origin. Okay, and then for cat 2 is 4 points on the circumference. Okay, so that means next time if you ever face any questions on properties of circle, all you need to ask yourself is whether you see 3 points on the circumference and origin or 4 points on the circumference. Then you can start to know whether you should use cat 1 or you should use cat 2. Okay, so I hope I have given you a very good summary here, and hope to receive many feedbacks from you guys. And that's all for today. I hope you have enjoyed my video. Thank you so much. Bye bye.